Am I talking about my results?
No, yeah, you must please let me know for the first test. You can let me know what you got. But Ramatullah just wrote his cycle test, so I'm still waiting to hear what he got for his cycle test. But for the first, evaluation test, you can let me know. We're going to look at integers. Now, with integers, last year, it was like still very simple because it was without, in grade 8, we actually also did with x's. Now it's just going to get slightly more complicated with the x's. So when I multiply, the first guideline that I give everyone is I always say, first multiply the sign, then you multiply your whole number. Am I still there? I thought I'm gone. You don't want to stare at my face during the whole lesson. You first sort out your sign, then you sort out your whole number, and then you sort out the variable in that order. So if I look at this one, it's a negative times a negative, so it's a positive. Then I'm going to look at my whole number. There's the invisible 1 there, so it's going to be 1 times 2, which is 2. Then there's a x times a x. So you know what we do? If you multiply the bases, you add the exponent, so it will be x to the power of 2. Just want to make sure, I think I got this out of the classroom math, so it's not out of the mind action. I decided to include the B one because can you see how nice it is? It's similar to the first one, but it has a plus in the middle. So this means you're going to add, the like terms. So it's like saying I owe 1 apple. You see, it's the invisible 1 there. So you owe 1 apple and a positive and a negative. This is all you multiply. Just the positive multiplied with a negative, which is a negative. So I owe 1 apple and I owe 2 apples. Then it means I owe 3 of them. So if you don't like integers, you can pop into the calculator -1 and -2. Okay, this one. It's a negative multiplied with the invisible positive there. So it's going to be negative 5 times 3, which is 15, and the x times the x. So again, you multiply the bases. I remember this or teach this in grade 8. I say you multiply the bases, so you add the exponents. And you see the multiplication looks a little bit like the addition. So it's 1 plus 1 is 2. And I always say if you divide the bases, you subtract the exponent. So this looks like a minus. Okay. Let's look at this one. You will first, listen, please try while I'm doing it. You must also try and do it, while I'm writing it down. So you must sort of ignore me and then you try and do it while I'm doing it. A negative times negative, positive. 5 times 3, 15, and an x1 times an x1. So it means we add the exponents, so it's x squared. At one stage when I still had pupils, where I taught, the group's physical classes, that's the word I'm looking for. When I still had physical classes, at one stage, I had a pupil who was really struggling. It was like a question of not going to pass. Now, this specific girl, it's a situation I will never forget. She sat in my class, but she never wrote down anything. She just sat there and she watched me. And I thought, you will not pass. You're already not passing, so you're not going to make it. And I'm not going to say, write down. You know what happened at the end of the year? She won a prize for the greatest, the best improvement in a subject. And that was telling me something that very often you must have a fine balance between what you are writing down and what you are looking at and listening and understanding. Right, so it's also senseless to just sit down and write down everything like a parrot, you know. You must understand. So you must know yourself. Right. Okay, but we must practice as well. So yeah, it's a difficult, you must know yourself. But don't sit there and play games or do homework or switch off. That's what I'm trying to say. Okay, I owe 5. Positive and a negative is a negative. You owe 5 and you owe 3, so you owe 8. You see, this one, I owe 5. I had a grade 10 now, a new pupil. And she also said it was just by listening to my stories, she managed to get the best mark that she's ever got in maths. Just because she liked to listen to my stories, so it helped her. Right, that's not enough said, enough sermons. A negative times a negative positive. So this is like, let's make it a orange. I owe Ramatullah 5 oranges, but I have 3 oranges. So after I give him my 3 oranges, I still owe him 2. Or you just pop into the calculator this. It will get slightly more difficult now. It's still very easy. Negative
Ma'am,
times.
can you please go to the previous slide?
Sure.
Ma'am, so 8x to 1, ma'am, it didn't change because it's not multiplied.
Yes, exactly. So if it was negative 5x and a bracket, that's when you will say negative times a negative is a positive. 5 times 3 is 15, and x1 times x1 will be x to the power of 2. So that's where we normally get confused, is between, you know, when will you add them and when is it just like terms. All right. Please remember, multiplication you can indicate with a dot or with a multiply or with a bracket. You see, I think this is what is confusing, Siko, is because you see the bracket there. So the bracket here means that you are multiplying. While here, it's a plus, so it means it's going to be addition. Although we're going to multiply the sign. So you see, there's no plus or minus in front of the bracket. So now it's going to be a negative times. That means multiplied. So it's a negative multiplied by negative, which is a positive. 4 times 7, which is 28. Then it's x times. The bracket means times another x. It's 28x squared. As I said with this one, because there's a plus, so it's like saying a positive times a negative. You see the bracket means times. So it's positive times a negative, which is a negative. So that's why this actually is not, you know, is like terms, where you add the like terms. I have 4, but I owe 7. So if you pop this into the calculator, just that, going to give you negative 3. You see the difference between a like term and when you actually multiply them. This means a negative times a negative. That is a positive. So I have 4 and I have 7. That means I have 11 x's. You will get used to this. Now, they just start slowly starting to add more variables. So same thing, negative times, You see there's the invisible plus there. So it's a negative times a positive, which is negative. Then we do the whole numbers. 2 times 4, which is 8. That then is a squared times a squared. I'm just writing it down for you to understand. So it's a squared times a squared. That gives me a 4. Then this one, a negative times a negative, a positive. Then it's 2 times 4, and it's a squared times a squared. Okay, then these two, you can just see there's a huge plus, then you can see there's a minus. So we know these are going to be like terms.
Ma'am, if it's divide, ma'am, what happens to the A2, ma'am?
Okay, I'll do that now. Let's first do these two, then I'll do some division. A positive times a negative is a negative 4a squared. This you can type into the calculator. -2 and a -4 is -6. You owe 2 and you owe 4, so you owe 6. And because it's like terms, it stays a squared. This one, a negative times a negative is a positive. You owe 2, but you have 4. That will be positive 2. This you just do on the calculator. You don't have to write it down. With division, remember now, when you divide, you subtract the exponents. So when I see division, you can write this immediately. But now you're slowly getting more and more options, because this is like working with exponents. So I'll show you another option working with the same one. Firstly, I'm going to work with my sign. Like I said, you always do your sign first. This is a negative divided by an invisible positive. Or the fact that there's only one minus means it's going to stay negative. This is like fractions, plain fractions, 2 over 4. And 2 over 4 you can simplify into 1 over 2. Then what you can do with a square and a square, it falls away. So it just becomes 1. Or you can write this as 1 over 2. And remember, with exponents, what do we do? This is the little house with a cat at the bottom. Take the cat up and the cat becomes negative. You can say a squared times a to the power of -2 will be 2 minus 2, which is 0. And a to the power of 0 becomes 1. And that's just -1/2. Right. Okay, the more we do, the easier it will get. So these are also exponents. I quickly just want to ask something here. I'm just going to pause quickly. Okay, let's continue. When you see, you remember with exponents, if that is an even exponent and there's a negative, it will always become positive. So this will just be 25. So just remember with these exponents, it does form part of integers, although it's your exponents. It's like an overlap, So exponents and integers, everything sort of becomes 1 eventually. Yeah, what did I want to say? Yeah, so it's an even number. Oh, that's what I wanted to do. A negative and a negative is a positive. So if you sit with the even amount of negatives, like if that 2 was a 4, you You see, we did this with exponents, then it stays or it becomes positive. But if you look at this one, there's an odd exponent. So it means it's going to be a negative and a negative and a negative. So if that is an odd exponent and you sit with the minus in front of the number, it has nothing to do with a minus next to the exponent. If this was like a -2, then that's not going to, the odd and the even is not going to play a role with this negative. It only plays a role with this one in front of the number. So if that's an odd and there's a negative, it will stay negative. And then you multiply the mad guy in, which is 1 times 3, which is 3. And that's -125. This one is an even one, so it will become positive. And it's 7 to the power of 2 because it's 1 times 2. Okay, so we're sort of doing a revision of exponents as well. This one, I sit with 10 to the power of 2, but there's no bracket. You see, it's the difference between this one and this one. You see, there's a huge difference. Let me do it with this as well, just to show you the difference. If there's a negative, it means it's going to stay negative because it's in front of the number. It has nothing to do with my exponent. The 10 to the power of 2 is just 100. Same with this one. The minus is in front of the number. There's no minus, there's no bracket. So the 3 only applies to the 10, so it will be -1,000. Compare with this one. Now the number is in front of the 10, and there's an even exponent. So it means this negative will become a positive. Yeah, Siko?
Is it because in the one in bracket, you square the negative, which will be negative
Yes.
plus negative.
Yes.
But on the one without a bracket, you don't square the negative.
Yeah. In the one with a bracket. With a bracket, we square the negative. But with this one at the top, there isn't a bracket. You see, so it's just -10 times 10. That one, well, this one is actually -10 times -10. You see, this one, -10 times -10. That's why it becomes +100. But this one at the top is just the negative stays there, and it's 10 times 10, which is 100. Makes sense?
Yes, ma'am.
I hope so. So this one will be like 10 times 10 times 10. And this one is literally -10 times -10. You see, to the power of 3, so it means you write it out 3 times. But you don't have the time in the exam to write this out. What if it's to the power of 8? You don't have the time. So that's why you need to understand that if this is odd and there's a minus inside the bracket, it will stay negative. So it will just be -10 times 10 times. Now, it's very tempting with this type of question for pupils to say, oh, it's +100. Don't be tempted to do that. You do what? You always do the brackets first. So you do the bracket first. So if I was standing in front of the board, I would have said, cover this with your hand. You see, you cover the minus with your hand. So you forget about this minus. You sort out the bracket first. So that is even. It's going to become +10 times 10, which is 100. And then you say negative times a positive is a negative 100. Sharp. Some more of them. Right. This is, let's see what's lying ahead here. Oh yeah, and then I'm also going to do fractions. I know you are actually busy with fractions. I'll get there. This one is 5 to the power of 3. All right, we know that's 125. Don't be tempted to say negative and a negative. You do the brackets first. Odd exponent, that will stay negative. 5 to the power of 3, 125. And then negative negatives are positive. So it's 250. Now you might be tempted to think, oh, why must I understand all of this? I'm just doing it on the calculator. But it says without using a calculator. So you must show the steps. You can check with a calculator, but you need to show the steps. This one, 7 times 7 is 49. And you hear me telling you there's a bracket. So you do brackets first. That's an even exponent. So it will become positive. 9 times 9 is 81. So it's going to be 49 minus 81. You see? Okay, let's move on. This one. Yeah, so instead of popping it into the first, yeah.
Sorry to disturb, ma'am. Can you go to the previous slide?
Yes.
Ma'am, it's negative 32, ma'am. So, ma'am, how do you calculate that without using a calculator?
All right. What you can do, you can say 81 and 49. So think of you have 49 Rand in your pocket. Can you imagine that? You have 49 Rand in your pocket, but you owe me 81 Rand. So I want to figure out how much you want to figure out how much do you still owe me next month if you give me my 49 Rand. So I'm going to subtract this. 11 minus 9 is 2, and we borrowed there, so 7 minus 4 is 3. Now, Siko, you say to yourself, you only had 49 Rand, but you owed 81 Rand. So after you take away the 49, or you give it to me, you still owe 32. So it's a little bit of common sense, you know, to decide what you must subtract from what. But there's no harm done if you just, you know, I will work this out on the calculator and just show these steps. All right, just show those steps.
Ma'am, can you just say how much do you need to get to 81 from 49?
Yes. Yeah, that's excellent. That's another way of saying you just take 49 away from 81. Yeah, exactly. Okay, and I want to go slightly faster now because I want to do fractions. So I'm just quickly going to go through this, and to be honest with you, I am going to work some of them out on my calculator. So this is negative 4 to the power of 3. So because it's an odd one, it will stay negative. And 4 to the power of 3 is 64, right? So just go and double check it if you're not sure. But this is going to be negative 64 and plus 64. That's 0. You see, so if you just at least write that down, and if you're not sure what this is, you know, negative 4 to the power of 3, of course, work this out on the calculator. You know, who would know? And then you write the final answer. So just put in the steps. Even with this, show the teacher that you're doing brackets first. But you know, the idea is to understand how to do it. So that's why we want you to understand, and you won't always be able to do it with a calculator because we're also going to work with variables. So you have to understand the concept. Our odd exponents, it will stay negative, 2 to the power of 3. Okay, I'm first doing my sign. An even exponent, so the negative will become positive. Then let's work this out. It's negative 2 to the power of 3 is what? 2 to the power of 3 is 8. So it's negative. 8. And 3 to the power of 2 is 9. This is then positive times negative is negative. 2 times 8 is 16 minus 2 times 9 is 18. So it means you can just add 16 plus 18 if you want to. But I will do this on the calculator. You see? So I owe 16 and I owe 18. So all in all, I still owe 34 Rand. All right. We are there at number 2. Okay, there's 1, 2, 3, 4, 5, and then we start with fractions. For this one, you see it's big numbers. So I will use the calculator for sure. This is a negative. That's an odd number. So the sign will stay negative. As I said, show how you figure this out. That is odd. So it's going to stay negative. 3 to the power of 3 because you multiply the exponents in. Okay, let's work out 6 to the power of 3. And make sure you know how to work it out on your calculators. So it's negative 216. Negative times the negatives are positive, and 3 to the power of 3 is 27. So in this example, I'm not going to bother to work it out. I'm putting it into my calculator. Negative 216 plus 27. That is negative 189. If you didn't want to use the calculator, you can just find out what is the difference. And finding the difference is 16 minus 7, which is 9. You see what I'm doing? I'm just subtracting. I'm not bothering. And this must become 16, so this becomes 0. So that one is going to become 10 minus 2 is 8. And then you have to apply common sense. You owe someone 216, but you only have 27. So therefore, the 189 must be negative. Okay, this one, but you can get away with using the calculator. You're not in grade 7 anymore. Okay, so this one, it's square, so it means it's going to be a positive. Please don't think 1 to the power of 2 is 2. No, it stays 1. 1 to the power of 1,000,000 is still 1. Right, so it's a positive because that's even. Negative times positive is negative. 5 times 1 is 5. This one, an even exponent. Just to show you again, it will be negative. You see, we don't have the time to do this. Just do it to explain. So you see, this will become positive. That one will become positive. This one will become positive times a negative. So that will stay negative. So the final answer is going to be negative because there's positive, positive, negative. So final answer is negative. 10, so there's a 1 with 1, 2, 3, 4 zeros. And 5 times 5 is 25 times 5 is 125. Stays a negative, and now we just add 1, 2, 3, 4 zeros to the 125. A little bit of, grade 6 when we had to multiply with 1,000, etc. Okay, there's only these two, and then it's fractions. 4 squared will be 4 times 4, which is 16, minus 9 is 9, which is 81. Just pop it into the calculator, and that gives me negative 65. You see, or you can just say, 1 minus 6, and then it becomes 11, and you have to borrow 1 from the 8. But that's tricky to do. 11 times 6, minus 6 is 5, and 7 minus 1 is 6. I owe 3 and I owe 4, so I owe 7. 7 times 7, 49. Right, let's start off with fractions. And now I decided to, why did I call it integers? It's integers, but it's also integers combined with fractions. So it should actually say there fractions, not integers. Now, when we work with fractions, in grade 7, if there's a plus or a minus, you get your LCD. If it's multiplication, you cancel out. I like multiplication because I love just canceling out. If it's division, you change the number after the divide sign. Change after the division. What do I mean by change? You get the reciprocal. Okay, you get the reciprocal. So let's see. If I sit with a mixed number, I change into an improper always. And you see, because it's fractions, I'm going to change 3 into a fraction. And then 2 times 2 is 4 plus 1. Many pupils do forget because, it's grade 6 when we did change it to an improper fraction. So it's not a shame if you do forget. 2 times 2 is 4 plus 1 is 5 over 2. 3 times 3 is 9 plus 2 is 11. And with multiplication, you can cancel out. The sign, there's only one negative, so it stays negative. And I can't cancel out further, you see. So it's 5 times 11, which is 55 over 2. You can say 2 goes into 5 twice, 2 goes into 15, 7 times remainder 1, so 1 over 2. Sharp. This one, it's division. Change into an improper fraction. So yeah, if you do get homework out of this, oh, why is the exercise number not there? That's me. I didn't write down the exercise number, but it's under the fractions. Find action series. I should have written. Yeah, Siko.
Ma'am, the sum you just showed, ma'am, I do it without cancelling out because cancelling out sometimes confuses me, ma'am.
Okay, I know what you are trying to tell me, and I hate what I hear. So, Siko, you are doing this. 3 times 5 is 15, and then you are getting a big answer. Am I right?
Yes, ma'am.
Don't do it. I want you to quickly try and get used to cancelling out. I warn you, it's so much, it's safer. Right, so I'm going to show you how. You won't. Okay, if you do get confused, I know when you do get confused. It's when you have to do it over and over. And I agree with you. It can get very confusing. Even if I must mark a pupil's work, it's sometimes confusing because I'll show you now. So what I suggest you do is you cancel out one or two numbers and then you rewrite. I know exactly what you mean, and I do agree with you. 4 times 3 is 12, plus 2 is 14 over 3. Then I'm first going to change this one. 3 times 2 is 6, plus 1 is 7 over 2. You get the reciprocal. So I will cancel out 1 at a time. 7 goes into itself once, and I can cancel out across. You know that, eh? 7 goes into itself once, into 14 twice. You know, cancel out like horizontally, but you can, across. So then what remains? 2 times 2 at the top and 3 times 1. So it's 4 over 3. Do write it again then as a mixed number. 3 goes into there once and 1 over 3 will remain. Let's try and find a more complicated one. Remember, if it's division and multiplication, what do? We work from left to right. If it's division and multiplication, this bracket is only around the -4. It's not around the 1 over 3. So I'm going to work from left to right. So this is going to be divided by -4 over 1. See what I'm doing? I'm working from left to right. Now with division, we change it into, we get the reciprocal. And try shortcuts. Do you see there's a negative and a negative? So I know it's going to be positive, my final answer, because there's the invisible plus there as well. Now, 2 goes into itself once and 2 goes into 4 twice. So we can simplify this now. 1 times 1 is 1. This is what I mean, Siko, that you just do it one step at a time. 5 times 2 is 10. But please don't write the big answers. Do get into the habit, especially, later on, grade 10, 11, and 12. Your brain must learn how to simplify as you carry on, because we have to work fast. 10 times 3 is 30. I'm still looking for a more complicated one. I see plus here, addition and division. So it's order of BODMAS orders and stuff. So I'm just rewriting this one for now. And because it's division, we will put brackets around the division. Improper fractions, 7 times 3 is 21, plus 1 is 22. What I'm doing, I'm writing 11 as a fraction. If it's addition, you don't really have to change this one into an improper fraction, but I'm going to use 2 methods. Here I will change it, here I'm going to keep it. So 1 times 6 is 6, plus 1 is 7 over 6. So on the left side, I'm just going to keep it. Let's quickly do the bracket, because it's bracket and division. Find the reciprocal. You see here we can say 11 goes into itself once and 11 goes into 22 twice. See, it's not too confusing there, Siko. It's okay. So it's 2 times 1 is 2 over 3 times 1, which is 3. So here it would be plus 2, plus 2 over 3. This one, right? Now, you can, with addition, you can add the whole numbers. But when you subtract, it leads to too many problems, and I'm not going to bother to warn you about all the problems. So the safest is to always change it to improper fraction. But if you want to add the whole numbers, like 1 plus is nothing but 1, and then we put this in brackets, you can do this if it's plus, but don't do this if it's minus, because it's very often you sit with this, the second number that's bigger than the first one, then it leads to problems. This, what must I do? Get the LCD, which is 6. 3 times 2, and 2 times 2 is 4. So this is like 1, and 1 plus 4 is 5 over 6. So this is just 1 and 5 over 6. Let's do this one where you can get the LCD, which is 6. 3 times 2. 2 times 2 is 4. So, you know, you have two options. 7 plus 4 is 11. And 6 goes into 11 once, remainder 5. You see all your options. Okay, no questions so far? Okay, then next one. If I see a question like this, I suggest you split. Again, you don't have to listen to me and you might struggle. So I suggest you split them, meaning, what is this line? This line means divide. Again, you don't have to listen to me, but I suggest you do. So it's going to be 1 divided by 2 and 2/5. Why do I suggest you split it? Because it becomes like a number divided by a fraction. So eventually you sit with 1 divided by, huh? Sorry?
That's also how I do it.
Okay, great. 2 times 5 is 10, plus 2 is 12 over 5. You see, eventually it's going to look like this. 2 times 5 is 10, plus 2 is 12 over 5. Yeah, it's so much easier. And then you just flip it. While this becomes, you know, split it. No. Is this done? Just hang on. I just want to do. Let's just do this one. This one is in brackets. Siko, this one is especially for you because you said it confuses you if there's lots of stuff that you have to cancel out. Right, so do you see with this one, 24 goes into itself once, and the 24 we can cancel out. Now, this is a relatively easy one, but if it confuses you, what I suggested previously is that you cancel out once only, and then you rewrite, you know, the more simplified version. That's what I always tell my pupils, because I know, especially when I still had grade 7s as well, it becomes so messy, you know, with all the cancellings. Then I can cancel this one out and that one. So you rewrite the more simplified version, which is 1 over 1 now. And that will be 1 over 26. And then I will do what you say you do. 23 times 1 times 1, so it's 23 over 1 times 26. All right, so that's what I would do it.